Hello everyone, welcome to Kweku Online Study. Today we want to talk about A2 parametric differentiation. So first we need to understand what parametric functions are so that you can apply differentiation to them. When we talk about parametric functions, they are basically two or more functions that are not directly related. So if you look at the x and y functions here, the x function is in terms of t and the y function is in terms of t. So as you can see, x and y are not directly related. So what parametric differentiation does is to create a connection between x and y. So now, even though they are not directly related, we can try and find a connection. If x changes, how much would y change? And that is what we call dy dx, okay? So basically that's it. And it's going to rely heavily on our knowledge of chain rule and our general knowledge in differentiation, because point is you would have to differentiate a function. So if your differentiation is suffering, then chances are you would struggle a little bit with parametric differentiation. But if your differentiation is great, I think you'll be fine here, okay? All right, so in this lesson, we are going to see how we can use past papers, okay, to understand it, because past papers tend to, be sometimes quite tricky. So if we are comfortable with past papers, then we'll be very comfortable to write any exam under parametric differentiation, right? Okay, so let's start with this question. They want us to prove that dy dx is this. Okay, sometimes students see this and then they are like, oh, it's going to be hard. But I promise it's not going to be hard. Once we differentiate well, it's not going to be hard, okay? So we have x is equal to tan squared this, but it's best to write it as tan 2t all square. Why? Well, because if you don't write it this way, okay, keep in mind, all your powers, that's how you want to write it. Because if you don't write it this way, you wouldn't fully differentiate it. You will partly differentiate it, which is, some sort of correct, but then it's not the correct answer. So it's best to write it this way so that when you differentiate it, the x dt, you differentiate the entire function, okay? So 2 comes down, then you have tan 2t, then you subtract 1 from the power. Oh, you get positive 1, sorry. Okay, now we go inside bracket, okay? We differentiate the tan. When you differentiate tan, you get sec square 2t. Then we go into the bracket again because we differentiated tan. Now we are differentiating 2t. We differentiate 2t, we get 2. And this, we simplify, that gives us 4 tan square 2t and then sec square 2t. Now, remember, this is where we are coming to. We are coming to a place where it has only cos. So you might want to simplify this, or you might want to keep it like this. Go and differentiate the y and see if it will simplify anything. But the truth is that the differential of the y will just give you negative sign 2t dot 2. So let's do that and see if we can find a connection over there. So we know that y is equal to cos 2t. So dy dt, don't write dy dx. Dy dt is going to be negative 2 sine 2t. And the reason is you differentiate cos, you get negative sine, right? Then you differentiate the 2t, you get 2. That's why I wrote that. Okay, now the next thing is we need to write dy dx. And this is where I show you how to do a good chain rule setup. So you write dy, okay, then you write a dx. Because the dy is the numerator, dx is the denominator. Then, okay, we bring our multiplication sign here. Now there is a variable that we've been using so far, a third variable, because we've mentioned the dy, we've mentioned the dx. So the third variable is dt. So we write it dt to make sure that it is aligned. So this is dt and this is dt. It's aligned diagonally. Because if we try to simplify, cancel out dt, we get back our dy dx. So this is how we set up the chain rule. All right, now what is our dy dt? Dy dt is negative 2 sine 2t times, what is our dt dx, not the x dt, because the x dt is this. So dt dx will be a flipped form of this argument. So 1 over 4 tan 2t sec square 2t. Now, as you can see, nothing really cancels. So what we can do is to simplify this side. Okay, let's simplify that. Maybe something will cancel. So we have 1 divided by 4 tan this. So okay, let me just write it quickly. I wanted to use a shortcut, but I think you will appreciate it if I use more steps. So 1 divided by 4 sine 2t over cos 2t times 1 over sec square means cos square 2t. Now look at the denominator. 2t, 2t. You can multiply them. So we have negative 2 sine square 2t 1 divided by 4 sine 2t over cos cube 2t. Right. So that's great. Now, the division becomes multiplication. So you have times and then you flip it upside down. You have cos cube 2t over 4 sine 2t. Good news. This cancels that. 2 goes here twice. So your work is now negative half cos cube 2t. And if you check, that's what they wanted us to prove. And that is what we have proven. All right. So that's how it's done. It's not that difficult. You just have to be okay with differentiation, really. All right. So if you're enjoying this lecture, you know what to do. Give it a like, give it a sub, and let's grow this channel together. Okay. Now let's go to the part B of the question. It says that we should find the equation of the normal, and then they gave us the t value. Well, it's good they gave us t value because that's what is going to help us to find the derivative. Okay, so we know that our dy dx is negative half cos cube 2t. So all we have to do is to put the t there and we are good to go. So we have negative half cos 2 times pi on 8 all cube, and this should give us negative root 2 on 8. So that's the gradient, and this gradient is for the tangent. Therefore, gradient of normal will be negative 1 divided by this, and we should get 4 root 2. Okay, and then we need to look for our x and y values. Okay, so go and grab the x. They said x is tan square 2t. In other words, it's tan 2t all square. Then we shall put our t value there. So we have tan 2 times pi on 8 all square. And that will give us 1 because tan pi on 4 is 1. 1 square is still 1. Then we have y is equal to, y is 2 cos 2t. Cos 2t. So we have cos 2 times pi on 8. That's the t value. And y becomes, that's pi on, cos pi on 4. That's root 2 on 2. We know that our equation of the line is going to be mx plus c. So we have our y value to be root 2 on 2. We have our gradient to be 4 root 2. We have our x value to be 1. We have plus c. We solve for c and we get negative 7 root 2 on 2. So we can therefore say that our equation is supposed to be 4 root 2 x minus 7 root 2 on 2. So now this is our equation of the normal for 4 marks as well. So as you can see, it's not that bad, right? Yeah. Okay, now next question, we are told that we should just find a gradient. It's not like find any equation or prove dy dx or something. However, they said you must simplify your answer. So we do not want to leave the answer unsimplified. All right. Oh, well, we thank them for writing the x as ln t all square. It makes it easier for us to deal with. Okay. So to differentiate this, the x dt would be 2. All right. Then we have ln t power 1, because you see the 2 comes down to multiply and subtract 1 from the power. That's what you get. Then we go inside to differentiate ln t, and if we differentiate ln t, we get 1 over t. Therefore this becomes 2 on t ln t. We know our y is e to the power 2 minus t squared. So dy dt would be negative 2t e to the power this. So we have our dy dt as well. Then it's time to prepare our dy dx. And like we said, dy dx is simply dy, something we don't know, and then ends with dx. So we check what is the variable missing. That's the t, dt. Therefore, dy dt, which is negative 2t e to the power this, times the t dx, and the t dx is going to be the flipped of this. So you get t over 2 ln t. Okay, so our derivative is basically negative this. Oh, you know what? Let's just cancel the 2's out. So this will cancel that. So we have negative t e to the power this. No, t times t is t squared, all over ln t. Well, they told us that t is what? Equal to e. So when t is equal to e, then our dy dx would be negative e squared e to the power 2 minus e squared all over ln e. Well, you know what the value of ln e is, right? Ln e is 1. So we have the numerator becomes negative e, and indices says add the power. So you get 4 minus e squared. And this basically becomes our gradient. And we have simplified it. So I'm pretty sure we are getting all the 4 marks right there. Okay, so you can see it's not hard at all. It's easy, really. It's so easy. Let's look at another one. So we are told that, let me start with red. X is going to be this. So maybe I should write it as t to the power half plus 3. And they want us to find dy dx in terms of t. But they said it has to be what? Simplified. If you don't simplify it, you're not going to get the 3 marks. Right, so please read the questions well, okay? So that you know very well this question, you can score all your 3 marks, and not because you made some, oversight mistake. No, read well. So we have our y, dy dt is 1 over t. Now we are going to have to simplify. So dx, dy dx is dy dt times dt dx. By now, you should know how to set the chain rule up easily. So this becomes 1 over t times. Can we simplify this? Yeah, maybe, yep. We'll get 1 over 2 root t. So that I can flip it and just write 2 root t like that. Yeah. So this will be 2 t to the power half minus 1, okay, because it's dividing. I mean, we all know it's going to be like this, and because of indices, blah, 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 and this will give us 2t to the power negative half, right? So this is a very simplified one, and that gives us our 3 marks. Then the question went ahead to say that, hence, we should find the coordinate of the point on the curve for which the gradient of the normal is -2. Okay, so there are two ways to do this question. You can, because we know that dy dx is equal to this, can I just even, either write this, or I can just write 2 over root t, right? Okay, so I can say because dy dx is this, then the normal is going to be the negative reciprocal of this. All right, so I can say that, well, then the normal gradient, so for normal, I'm going to get my gradient to be -1 divided by this. And I set it up. Or you can also argue that if my normal gradient in the question, okay, if normal gradient is -2, then the tangent gradient is going to be half. And then you can equate this half to this. Okay, so tangent equals tangent. Or you can equate this normal gradient to this and also solve for t. So it's really up to you what you want to do. I think it would be easier to just work with the tangent version of it, even though the question is normal. But that's what I think. It doesn't mean it's the absolute truth. You could also do otherwise and still get it right. So I'm just going to stick to the tangent argument. I know by now you are wondering, sir, why don't you just work with the normal? Well, because the tangent looks easier to me, all right? So we know t is 16. But the question didn't say find the value of t. It says find the exact coordinates of the point on the curve. So what point do we have? We have x and y. So we are going to argue that x is root t plus 3. So that's root 16 plus 3, and that is 7. How about y? Well, we know y is ln t, so y is equal to ln 16. All right, so you may say that, well, 16 is 4 squares, so we want to write maybe 2 ln 4. Like, it doesn't even matter. You can just leave it like that. It doesn't even matter. So your point is 7 comma ln 16. Somebody will say that the point is 7 comma 2 ln 4 because 4 squared is 16. They are just trying to show off. It doesn't even matter. Just write one of them and be free. So this will give you what? 6 marks? Yeah, A and B, not bad. Then these are the big boys where you get 5 marks for just the first part. But I'm calling it big boys because it's 5 marks, not because the question is going to be hard. I really don't think it's going to be hard. I think it's going to be easy if we differentiate it well. All right. So if you look at the x, we need to apply quotient rule of differentiation. Like I said, you need to know your differentiations. So we have the x, the t, the theta, not the t. Oh, because we've been writing the t, don't worry about that. All right. So we are going to we differentiate the numerator. That's negative sine theta. Then I'm going to keep the denominator. Then minus. Now I'm going to keep the numerator, differentiate the denominator. I'll get negative cos theta all over the denominator square, 2 minus sine theta all square. All right. Maybe I can simplify it a little bit. I'll get negative 2 sine theta plus sine square theta plus cos square theta all over this. Now, if you remember this identity, sine square plus cos square, if you don't remember, go to your MF19 and check this guy right here. Oh, let's use the color on it. Check this guy right here. And that says it's 1. So if it is 1, then that means the numerator, the numerator is going to be 1 minus 2 sine theta all over this. So all of this is just the x d theta. Then we grab the y. The question says this is y. So that's 2 plus theta plus 2 cos theta. Did I write it wrong? Yep. And we differentiate it. So dy d theta is 1 plus negative 2 sine theta, I think. Yep. So we can just write as this. And now we are going to set up our dy dx. So dy dx is going to be dy d theta times d theta dx. So what is our dy d theta? Is 1 minus 2 sine this times our d theta dx. Remember, this is dx d theta. So now d theta dx will flip. So we have 2 minus this. 2 minus this all square over 1 minus this. As you can see, good news. This cancels that. And we are right there. Okay. And that's what they wanted us to prove right here. So like I said, it's not because, oh, it's 5 marks, so it's going to be hard. No. It's not. It's really about the differentiation. So if you're able to differentiate well, then chances are you are going to get it right. If you don't differentiate it well, then you find it a little bit harder to show it. So work on your differentiation. Really, that's it. Okay, then we are given another one, show. And this, as you can see, is 3 marks. So, chances are going to be pretty simple. Okay, so let's start with this guy. We have 2 functions that are multiplying. So it is safe to say that we use product rule. So I'll differentiate the t first. I'll be left with this. Plus, now I'll keep the t and differentiate the e. I'll get 2 this. So should I factor something out? I don't know. No, maybe I should just leave it like that. Sometimes you can easily see that maybe we can factor e to the power. Yeah, let me factor something out. Because what if it will cancel with something, right? If it doesn't cancel, we can always expand it. And now we have our y to be t squared plus t plus 3. We differentiate, and this is 2t plus 1. Oh, I see it. It's good we factor this. So dy dx is dy dt times dt dx, and dy dt is 2 plus 1t times dt dx. That means we flip this guy upside down, and that's going to be 1 over this. And the good news is this and that will cancel, so we have 1 over this. What do they want us to prove? Oh, they want it this way, so we bring it up. So e negative 2t. Like I said, I had a feeling that's going to be easy, like pretty straightforward, and that's what it was. Let's see, is there b part? There's no b part. Oh, sorry, I didn't extract that. Now, we've been given this question that says that we have our sine, we have our, sine, our x and y, and a dy dx should be cot t. And that's 5 marks, so chances are it's going to be involving, not difficult, but rather involving. So let's see how that goes. So we differentiate the x, we get 2 minus, differentiate tan, you get sec square t, right? And then you differentiate t, you get 1, so that's it. And this is dy dt, dx dt. We take the y. Now, if we differentiate, to differentiate a ln, it basically means differentiate what is in the bracket over what is in the bracket, okay? So we differentiate sine 2, sine 2t, we get 2 cos 2t over what is in the bracket, which is basically sine 2t. So this technically becomes 2 cot 2t. Okay. And now we know that our dy dx is really going to be dy dt times dt dx. So our dy dt is 2 cot 2t times dx is going to be flip of this. Okay, so I think that we should probably simplify this side. All right, we have to, because if not, I mean, I don't see any way out for us. Even this cot, I think I should just write it as cos 2t over sine 2t, because these are double angles, and maybe something will pop up. So times, this is 1 divided by 2 minus sec square t. And we know that sec square t is going to be 2 minus 1 over cos square t. So let's solve this particular fraction. All right. So, hey, where from the 2? Was it 2 or 1? Okay, it was 2. Okay. So we are going to have 2 cos 2t over sine 2t times 1 divided by, then I have 2 cos square t minus 1 over cos square t. And then I still have a few more steps to go, but I think I see the light. So this becomes 1 times, then cos square comes up, and this goes down. And that means we have 2 cos 2t over sine 2t times cos square t over 2 cos square t minus 1. Now, if you check, this and that are the same. Why? Because check the identity for cos 2a and this. They are the same. 2 cos square a minus 1 cos 2a are the same. Therefore, I could easily cancel out these two, claiming that they are the same. Okay, next argument is the sine 2. Okay, that in our MF19 is 2 sine t cos t, right, times our cos square t. And here too we can see a couple of cancellations, such as 2 cancelling 2, and then cos taking 1 of this. So that means that we are left with cos t over sine t, and that is cot t, and that is what they wanted us to prove right here. Okay, so this one was a little bit, like that, but we just have to pay attention, otherwise we are likely to make a mistake. But I think we just paid attention to every detail, so we got that right. Now another could be given. So now you are seeing a pattern. I think this is the last question or so. No, the last but one. Okay. So if we are given something like this, how do we go about it? We have our x, we have our y. It's just the same pattern, right? Maybe you might think that this is probably going to be hard because it's 5 marks, but it's not. I don't think so, but let's check it out and see. Okay, so the x, I'm going to write as cos t to the power negative 1. And then I can differentiate the whole thing. So the x dt is negative 1 into bracket cos t power negative 2. Okay, if you subtract 1 from the power, go inside the bracket, you get negative sine t. All right, so we're done. And this is going to give us sine t over cos square t. Then I would take interest in my y. which is given as this. And remember, to differentiate a lane, you differentiate this guy over itself. So I have dy dt, that is going to be sec squared t over tan t. And that really means I need to simplify, because I don't, where we are going is here, sine and cos, and I have sec square and tan, so I should probably simplify it so that it will make it easier for me. So I have 1 over cos square divided by sine t over cos t. So this will become 1 over cos square times cos t over sine t. And as we can see, this and that will cancel, so we have 1 over sine t cos t. Okay, so now we can set up our chain rule. So dy dx equals dy dt times dt dx. And dy dt is 1 over sine t cos t times dt dx. So it flips down to become cos squared t over sine t. Okay, so this guy must flip. Okay, so cos would cancel one of this, and then we get cos t over sine squared t. Is that what they want? Yep. So it's good to look at where you are going, so that if you have to simplify, you simplify, and that helps. And because we just did it. Because suppose I had not simplified this and I left it as it is, I think we would have struggled. But because I simplified, it made the job easier. So that's the A part. The B part said we should find the equation of the tangent where y is equal to 0. Remember, we did one, they gave us where the t value, but this one they gave y. So that means the whole argument starts from the y. You know that your y is equal to ln of the natural log of tan t. So if y is equal to 0, then this is what we have. So you take the e of both sides, and you get 1 is equal to tan t. So t is the tan inverse of 1, and that should be pi on 4. Okay, so now that we have this, then we can look for our x and y values. In fact, let me start. You don't even need the y value because you know y is 0. So x is going to be 1 over cos t. So 1 over cos t. And t is pi on 4. So we have 1 over cos pi on 4. And our x value becomes root 2. So our point is root 2, 0. We need to find the gradient. So dy dx is cos over sine square. So cos t over sine square t. So this will be cos pi on 4 over sine square pi on 4. And that should also give you root 2. So your tangent is going to be y is equal to, of course, we're going to use y equals mx plus c. Our y is 0. Our gradient is root 2. Our x is root 2 plus c. Root 2 times root 2 is going to be 2, right? Yeah. So c is negative 2. So y will be equal to the gradient 2x, root 2x minus 2, like that. So this is the equation of the tangent for 3 marks. Okay. All right. Is this the last question? Yes. Great. That's also a 5 mark. I'm happy that I finished the worksheet. Okay. It was my plan to finish it. All right, so we have our x giving us this. So let's differentiate it. So we have dx d theta should be, if you differentiate cos, you get negative sign, but because the cos is already negative, you just get sine. And dy d theta, why am I writing dy dx? Dy d theta would be, we differentiate the cos here, we will get negative sine, and then we differentiate, so we keep the negative 1 over 4 there, differentiate the cos, we get negative sine 2t, differentiate the 2 theta, we get 2, so the whole thing becomes negative sine this plus half of sine 2 theta. Okay, where are we going? Oh, this is not sine x, it's sine theta. So we are coming to this side. Maybe we should just set up our chain rule and see if something will cancel. I don't see it though, but I mean, who knows? So this is dy d theta times theta dx. So dy d theta is negative sine this plus half of this times 1 over sine that. Okay, so this is what we have. So what can we do? What can we do? Maybe we should start by simplifying stuff. Because this is a fraction that we can deal with. So maybe we should deal with it. So I'm going to have negative sine this plus half of sine 2 theta from your MF19 should be 2 sine theta cos theta, right? So times this 1 over sine that. I'm going to keep that one there for now. And then 2 cancels 2, so I have negative sine theta plus sine theta cos theta times 1 over this. Okay, so what can I do here? We cannot add this guy, but we can factor. So I'm going to factor sine out. So if I factor sine theta, I get negative 1 plus cos theta times 1 over sine theta. Oh, that's good. So that this and that will cancel, right? And we are left with cos theta minus 1. So this is where we are going to, and we are right here. At this point, you might think, how do we get out of this jam? Well, let's visit our friend called MF19, right? But before we visit the MF19, remember that this is the connection we are looking for. We are looking for a connection between cos theta and sine square, right? And sine square theta, like any connection, because this is where we are, and we want to prove that we get negative 2 sine square half, blah, blah, blah. So, like, this is what we are looking for. So if we go into the MF19, we are looking for a link between cos theta and sine square theta. Okay. So we come here. If you take this one, we have cos theta and we have sine 2 theta. It's not sine square, so we abandon it. We have cos theta, sine square theta. That is good. Or we can use this cos theta and we can use this sine square theta. And I think that's what we should use. Okay, so let's pick that one. So now we know that cos 2 theta is 1 minus 2 sine square theta. Okay. What we want is cos theta, not cos 2 theta. So we need to modify by dividing each angle by 2. So the moment we do that, we get 1 minus 2 sine square half theta. Then we take this back here because that's the definition. So therefore, dy dx equals cos theta, which is this, minus 1. So this and that will cancel, and we get negative 2 sine square into brackets this. And that is exactly what they wanted us to prove. So don't think that, oh, you are stuck. No, you are not. You are not stuck at all. Just go look at the connection you want to create. You want to create a connection between cos theta and sine squared theta. Then you go to the MF19 to look for such a connection. You may not see it as exact, but you pick any connection that you can create there and come and modify the connection to do the work. Okay, so this is where we would end with this parametric differentiation on P3. The worksheet will be in the description, and also you can check out my channel. I'm going to make a video to introduce all of you to my website. Yeah, a student of mine, Iraja, has created a website for me. I'm so excited about it. So in the coming days, I'm going to take you through the website so that everybody can just go to the website and get all the videos and worksheets that they need. All right, thank you very much for sticking around to this question. See you in the next video. Bye.